Welcome to Introduction to Programming with JavaScript for Web, George Brown course 9688. My name is Emilio Incerto and I'll be your instructor for this course. I usually teach this course in person at George Brown. This is the first time we'll be doing it online and I'm really glad to see you guys joining me. We have a lot of students from different areas. This is the first time I think we have some students from outside of Toronto taking a course, and that's why we're doing these online courses. So welcome to everyone. I may have met you before in class or not, but hope to get started. So the first thing I want to say is who this course is for. Obviously, if you're taking the development or the design certificate, you need to take this course. It's a basic JavaScript course, and JavaScript is a part of online languages. It comes in tandem with HTML and CSS. But this course here is really designed around beginners who don't know how to program yet. And when I say program, I don't mean HTML or CSS. I mean writing a language that can kind of think and use some logic to it. So let's get started. I'm going to show you guys around a little bit. I've got some slides that I'm going to use. I've got an online course that you've probably already seen because you're seeing this video. And let's get right into it.
Let's start off by looking at my desktop. You're going to notice I don't have much there. Trust me, this isn't my usually cluttered desktop. This is just for you guys. I've only got two programs on here, and that's because when we're writing JavaScript, we're going to be doing a lot of just text editing. Now to write this, sometimes you may have used Dreamweaver, Adobe Views, Microsoft FrontPage if that still exists. Some people still use it. I don't want you guys using anything else but a text editor. We're going to be using either Notepad++ or Sublime, and I'll show you links for that in a moment. The other program we're going to use is Chrome. Now that's because it's cross-operating system, it's compatible on Mac, on PC. You could have a Chromebook. I'm not suggesting you use a Chromebook. I really want you guys to have a PC or a desktop with a keyboard, with a mouse. It'll help everything kind of go a little smoother. But the reason why I want to use Chrome is so that when we're testing, and you're on a Macintosh and I'm on a PC or vice versa, I can really make sense of the issue you're having, test it on my system, and know that we're in the same program. That way we're not troubleshooting your operating system or the programs you're running, we're just troubleshooting the code itself. So I'm going to go ahead and start showing you a little bit of an introduction to the course website. You've probably been there right now, you're probably watching this video on it right now, but I just want to give a quick overview of the whole thing. So let's go ahead and open up Chrome. If you don't have Chrome installed, go ahead, pause the video, right, that's the benefit of these videos, and come back. So here we go. In the URL bar, I'm going to type in emilio.com/gbc9688, the course code, and we will see Introduction to Programming with JavaScript for Web appear. Here we've got a menu. You can see the course overview, which is the course breakdown. We've got a menu with all the lectures. We're going to have 7 of these over the next few weeks. You'll see them populate as we go every Monday. And then we can log in here. We can also log in on the right-hand side. Before I log in, just want to show you that you can hit lost password. And if you don't know your password, you're having trouble logging in, go ahead, type in the email address that you have registered this course with. If you're having trouble with that, email me at emilio@emilioi.com. I might be able to help you reset it, but try doing the lost password first. Other things we're going to notice in the sidebar before we log in, we've got a link to W3C Schools. That's going to be a reference for a lot of this course. So if you guys need to look something up, I highly recommend you going there. Then we've got a link to Notepad++ and Sublime. So like I said, Notepad++ is a text editor. You can run it on a Windows PC environment. I'm going to be using it throughout this course. If you prefer to use Sublime and you're on a Macintosh, you'll need to use Sublime. Download it here. It'll also be a text editor, and you Windows people, you can also download Sublime if you prefer it. Windows is a little more dark. Sublime has a dark theme by default. Notepad++ has a light theme by default. So I prefer the light theme just because while we're working, it's going to be easier for you to read my code. Alright, let's go back and log in here. My username is Incerto. It's the first initial of your first name plus your last name, and then the password is going to be your George Brown student number. So hit login. You can remember me. Why not? And it doesn't look that different. The only thing different here is this thing here, access your sandbox. Now if you click that, you'll get a new window open up. It's a little bit of a code playground, a code sandbox. We're not going to use this in the first week or two. I really want to get you guys used to working with Notepad files. So we'll come back to this later. For now, you can just ignore it. And then you can hit Lecture 1. So here's another quick overview. Every lecture, I'm going to post some notes. I'll post an assignment. You'll be able to submit your assignment here on this Lecture 1 area. But the thing that I think is a little neat for this course, and something that I've added, is the ability to watch videos and comment as you go. I think because this lecture isn't going to be in person, or I get interrupted by students, maybe someone has a question, and I can kind of draw my answers out a little bit. Well, you're going to be able to ask me a question right at the second on this video, and I highly recommend you do that. It says access your sandbox. I'll open that link up. It's a little bit of a code playground that I've created. We're going to use this in weeks 3, 4, 5, 6, 7. Right now, we're not going to be using it, so you can just ignore it here on week 1. The other thing to notice is you've got a link to your dashboard. You'll be able to see your grades as I mark everything as the weeks go by. And here we've got profile. I'm going to click profile because I want everyone to upload a picture. We all have our pictures online nowadays. You may have your face on Facebook, on LinkedIn, on Twitter. Ideally, I'm going to prefer that you upload a picture of your face just so that we're writing comments back to each other and so other students can see. We're going to have a little bit more of a sense of community, right? It's nicer to see a friendly face. If you don't prefer to do that, please upload something that represents your personality. A flower, a beach, something that you think says you. So I'm going to go ahead, click choose file. Here's a picture that was taken at Rooster Coffee just on King Street, George Brown campus. And did that upload? Let me just double click it again. Choose file and update profile. There we go. There's my picture. Every time I write a comment, you're going to see my picture appear with it. This area here is your dashboard. When you want to get back to the course website, just go to the top left of the screen and hit Visit Site or Introduction to Programming with JavaScript. They'll both get you there. Let's look at another feature of this website. Lecture 1, we'll click on it here. And what I'm doing to kind of, again, encourage community as we go through these different weeks is adding an ability for you to ask me a question right at the time code on the video. What does that mean? Well, I'll show you a quick example. And as always, you're going to see a lot of these. I've got a lot of Ben Affleck examples in here. Not meaning to poke fun of him too much, but sometimes he's just an easy target. So here's a video I'm posting on Lecture 1 before Lecture 1 is posted because I'm recording Lecture 1. I can't have myself already there. I'm not in the future. So I put up this Ben Affleck video. If anyone's seen it, it's kind of funny. I'll turn that down. It's just an interview that Ben Affleck did. You can see he's sad. And all of a sudden, someone kind of zooms in very, very slowly on Ben Affleck. And here we are. Okay, so say I want to ask Ben, hey Ben, what's going on? What's wrong? I'm going to hit start. It'll play the video. Then I'll hit end. I've now created a time code and I can leave a little message. I'll say, hey Ben, why so sad? I can hit submit. There's now a comment there. I can see it, the whole class can see it. Now don't be shy, I want everyone to be asking questions. You're going to find out we're all beginners, we're learning a new language. I'll get to that in a bit, so please don't be shy. I can then reply, I'll reply to myself for now and say, I wonder if it's because Batman wasn't his best work. Hit submit, and look, now we've got threaded comments. If I see these comments, I can click on commented on. I'll be able to see exactly where you left that comment. So I'm really hoping everyone can use that throughout the course. We won't see any more Ben Affleck videos just yet. This is going to be my face, but please go ahead and use the comments. So I think I've got all of the nitty-gritty of working with a website and logging in out of the way. I want to talk a bit now about an introduction to the course, what I expect from you, what you should expect from me, and then I'll go into a brief history of JavaScript. Today I'm going to also talk about creating JavaScript files, running our first program, writing a command, programming command, creating a variable. What does that mean? It's the way a computer can store memory. We'll get into that. How does a computer handle numbers? How does it handle phrases? Two different things. How does it compute numbers? Can it add numbers? Can it multiply numbers? How does it put a phrase into a paragraph or a paragraph into a page? So those are our number operators and our string operators. And then putting that all together with variables and the statements that we'll have learned by then, we're going to create expressions, organize our code, and then I'll give you your first assignment, and you guys will be writing your first JavaScript files. So I'm going to go ahead and open up a slide deck that's also posted online. I may go full screen on these slides once in a while. I may go off full screen, but you can follow along in the PDF that I've posted or follow along in the video, whichever you prefer. All right, here's our first slide, first lecture, right? Lecture 1, we're already about 10-15 minutes in, so I'm going to get the ball rolling. I know this isn't in person, I don't want it to last too long, so let's get going. Introduction to programming with JavaScript. What you need to know. Ideally, you have a basic understanding of HTML markup, how an HTML page is structured. I'm going to show you how an HTML page is structured if you don't. But aside from that, I'm not assuming anything. I'm not assuming you know how to write a web page and put it online. I'm not assuming you know how to make your text blink. I'm not assuming you know CSS layouts at this point. I'm really coming to this course to help you guys understand how to program, and we're going to do that with JavaScript. So it's our helpful language, but we're going to be learning a lot of concepts that are true to C++, C#, Python, Visual Basic Script, Swift code, all these different languages you might have heard of, Perl, Ruby on Rails. We're going to be learning the basic components that applies to all these languages. Just like French has nouns and Italian has nouns and Chinese has nouns, and you've got pronouns and proper names, sentence structure and grammar, same thing holds true with programming languages. So if you learn the basic concepts of how to name something in a programming language, how to add two things in a programming language, well, you just have to know the different words for JavaScript, but you could also learn the new words for C# and you're not changing your concepts. So a lot of this course is about learning those concepts. Now, I'm not requiring there be any textbook. If you want, you can use this book, Eloquent JavaScript. It's a free online download to help you out. There's also W3C schools, which I'll point to, and I'll show you that in a moment. The reason I'm not going by a book is because I find them to be a little overwhelming. Now, programming languages in general are quite complex. They have lots of libraries of code to do everything from track calories on your fitness band, to do the square root of 9, to figure out the tangent of a curve. We don't need to see all that. I don't want you to get overwhelmed at this point. That's why for this course, we're not going to be using a book, because I find they often are targeted towards very advanced programming concepts for people who already know programming. And then the other ones are a little too simple, so here we go. Let's see W3C schools. I'll just click on it right now to open it in my browser. You've probably seen this before. Oops, some slides went. I'll have a lot of links here and tell you what you need to know, what you don't need to know. So for example, random JavaScript numbers. You don't need to know that for this course. We might get there eventually, but for now, we don't need it. Date methods. How do you write January, July? All of these different things. It's going to be overwhelming. As you can see as I scroll through, this is just a few basic things. So again, let me guide you through this course. Now let's go back to my slides. And talk about programming language concepts. So here's a little bit of an exercise. You can do this with a pencil and paper. I'll do it with Notepad in a second, but let's think about what a programming language is. Some people think of programming as math. Some people think of it as code. The truth of a programming language is it's like raising a child who doesn't know how to talk, who doesn't know what is what in the world. It's like having a newborn baby. It's potentially very, very smart. But when it's just starting off, It doesn't know the difference between a spoon when it's hot or cold. You have to teach it that type of thing. It doesn't know words. So it has huge capabilities and complex algorithms. It has a brain. It just doesn't know how to use it. So my best example for this is thinking about how you would tell, let's say, a 4-year-old how to bake a cake. Let's simplify that even more. How would you tell a 4-year-old how to make a peanut butter and jam sandwich? Right? You'd probably tell them, go to the fridge, grab some peanut butter, grab some bread, grab a knife, make sure it's a safety knife. You take 2 pieces of bread, put something in between, that's what we call a sandwich. Let's put peanut butter between. And you can assume that the child, 3 or 4, maybe 5-year-old child, could manage that just fine. But now imagine you're talking to a robot, right? Again, we know there's a lot of complexity there. It knows how to do things. It's got a calculating program in its head. But to give a robot every single instruction to make peanut butter and jam sandwich, well, there's going to be a lot. So I really want you to pause the video right now, open up Notepad, unpause the video, and I'll show you what I think you need to give instructions to a robot to make a peanut butter and jam sandwich. Well, actually, let me start you off before we pause the video. We'll say, here's Notepad++. It automatically opens up with a new file open. If not, you can always do file new if you want to make a new one. And I'm going to type in, how would we start this? Grab a knife. Well, let's go down to the end. I'll hit enter a few times and say, you've made a peanut butter and jelly sandwich. So now we have to get that robot from grab a knife to you've made a peanut butter and jelly sandwich. I'm going to pause the video, write out my steps right here. I want you to do the same, and then we'll see how many steps you have compared to the ones I have. Alright, I'm back with a few ingredients. Now you'll notice I don't have the peanut butter jelly sandwich here because I just ate it during that break, but let's look at all the different steps I have. I've got grab a knife, grab your ingredients. What are ingredients? Well, the ingredients are peanut butter, bread, and jelly. Collect the ingredients, open the bread, take out 2 slices, spread peanut butter on 1 slice, spread jelly or jam evenly onto the other slice of bread, press the pieces of bread together, cut the sandwich. You've made a peanut and jelly sandwich. I should say peanut butter. But you might say to yourself, okay, peanut butter, what's peanut butter? Okay, peanut butter is the brown, gooey stuff with 2 bears on it in the cupboard. What is green? What is brown? What are bears? You really need to tell a computer everything. And you don't realize it, but the simple act of you going to the fridge, making yourself a sandwich, takes a computer forever to learn. Even with artificial intelligence, everyone's talking about that right now, it still takes a long time to tell a computer how to do something, what to do. Now here's where I want to get you guys to at the end of the course. By week 7, your final assignment will be making a rock, paper, scissors game. Now I'm pretty sure everyone's heard of rock, paper, scissors. If you haven't, I'll put some instructions to it in lecture 1. But I want you to look at the camera with me and we'll play 1 round of rock, paper, scissors. So let's go. 1, 2, 3. I picked scissors. What did you pick? Did you win? Did I win? Let's do it again. 1, 2, 3. Did you win? Did I win? Have you won 2 games? Well, have you won 1 and I've won 1? Let's play a third one. 1, 2, 3. Scissors again. Now, how much did that take for you to think of that game? I didn't have to tell you the instructions. I didn't have to tell you what scissors is, why scissors is 2 fingers, or why a rock is a rock, a fist. You knew all that stuff. We're going to take 7 weeks to get to play that game, to get to writing the instructions for a computer to play that game. So I really I don't want anyone to be overwhelmed in this course. I want you to understand everything is a tiny, tiny step. A lot of people think about programming like math, and I started talking talking about that earlier. It's not really math. It's little steps and decisions that all come together. Sure, sometimes that's how does 2 and 2 come together to equal 4? That's a decision. But another decision is how does a fitness tracker track calories? How many calories are too many for a day? That's another decision. How many are too little? All that stuff comes together in programming. So let's go back to the slides. That's kind of what a programming language is about. A ton of tiny instructions that you already know. They're so intuitive to you, you don't know you know them. You don't even think about them. So here's another question. Why are there so many programming languages? Well, there's a lot of different things that programming languages do. Like I was saying earlier, you might have a fitness tracker. While some programming languages are better at talking to hardware than others. You don't need to run Windows on your watch, on your smartwatch. Your car doesn't need to be able to track calories. There's a lot of reasons why you might use one language over another because it has benefits running on hardware. It might be a low battery powered device, so it's not too complex. It might be a desktop machine like Mac or Windows, and you need a lot of things to run at once. You might be gaming on an Xbox or a PlayStation. Then you need 3D sprites and 3D models everywhere. A lot more information has to come in. So this is why there are different types of it. Some run better doing different tasks. And sometimes it's easier for a human to write 3D easier on an Xbox than it is to write 3D in HTML. It's just the way it works. There are languages for different purposes. So what is a programming language? I think I've gone over that a little bit, but English is a natural language. It is words, symbols, and grammatical rules. I've mentioned that. Programming language similarly has its own set of rules, symbols, and words. And we call that syntax, right? How you put the words together, your punctuations. That's really important. If anyone on this course has ever used a PET machine in Commodore or DOS, you may have seen a syntax error. It used to be one of the most common errors in the 80s and early 90s. That just meant a programmer forgot a period. They forgot a comma. They forgot a quotation mark. That's what the syntax error used to be. But syntax is still super important, and it's going to be probably the biggest type of error you're going to run into as we start coding. How do computers compute? Now, you can read the slide with me. Computers work line by line through an instruction set. And then think back to that peanut butter and jelly sandwich. We started at the top, and then we went stepwise down through all the different things we need to do, assuming that once we got to number 5, 4, 3, and 2 had been done. Once we got to number 10, 9, 8, 7, 6, 5, 4, 3, 2, 1, they were done as well. So computers compute by taking pieces and then moving on stepwise with the instruction set you've given them. We already saw that one. Here's an example of different types of programming languages. High level, which is what we're learning. That'd be like a C#, that'd be like a JavaScript. Then there's low level, which is hardware programming. So when you're sending a command to a motor or you're sending a command to your brakes, it looks like this low level program here. And then at the tiniest level, we've got binary, a bunch of ones and zeros. It looks like the matrix. That's our machine code. All these different codes live on machine code. So your computer is always running machine code. Your cell phone's running machine code. Your watch is running machine code. Well, digital watches, not the type with gears. And on top of that, they're all running a low-level program. Now, some things like your microwave never get beyond a low-level program. Your coffee machine. But if you want something to be more complex, on top of that low-level program, you have high-level program. Now, you can see which one's more human-readable. I'll always keep coming back to that idea of human-readable. You might not know what the top one means, but at least there's a lot of English there. And you can see some math operations happening. In the low-level program, okay, we're loading and mulling and divvying and reading. Who knows what that means? And then machine code, that's just not human speak. That's computer speak. So again, different languages have different things that they do well. What determines a good language? So the cool thing about JavaScript is it's everywhere now. You can run it on your computer. You can write apps with it. You can pretty much write the whole back end of Facebook with it. Facebook is doing some really cool stuff with really pushing the limits of JavaScript these days. Back a few years ago, a decade ago, it really mattered how many cycles your machine was using to execute an instruction set. So when you've heard these things like RAM or megahertz that we used to throw around, people wanted the fastest machine because things would happen faster. That's all it is. You want to open up an Excel spreadsheet, you don't want to sit for 5 minutes waiting for it to open. Now the thing is, at one point, all that performance cost battery life, so if you're using a laptop or cell phone. So you might notice when you're opening a really poorly programmed app or a 3D game, your phone gets really hot and the battery starts draining really, really fast. That's because you're really pushing the limits of that device. For the most part though, modern devices have really good performance, so even that game isn't going to kill your cell phone in a matter of minutes. It'll still take an hour, 2-3 hours of gaming before you get down to zero battery. So now what matters more is the human cost. How snappy is the UI? How fast does it load? Can it load over a cell phone connection pretty speedily? Is it human readable for programmers? So if you write a piece of code and then I write a piece of code, can I read yours? Can you read mine? That really matters these days because you have big teams working on things together. So JavaScript seems to be one of those languages that's really doing a lot of this. Here's an example of kind of what I mean. Let's compare two programming languages, the one on the left versus the one on the right. I personally like Python a lot. That's one of my favorite languages to write with. JavaScript has a lot of similarities to it. Now on the left-hand side, we have Java. Now Java is not JavaScript. They're two very different things. I'll get to that in a bit. The one on the left, just looking at it versus the one on the right, it looks a little more complex. It looks like there's a lot more going on, but really both pieces of code are doing the exact same thing. The benefits of the left-hand side, Java, is that that's a programming language that can run anywhere and you can really tweak every little point. The benefits of Python is that it's really easy to read and understand what's going on. Basically what these are doing is saying, let's take something and loop over it 5 times. Let's redo the same task 5 times. So if you could understand either of those, I'm guessing you saw the one in Python. You were kind of guessing what it was doing first. Okay, let's keep looking. What is JavaScript? I said it wasn't Java. You may have heard of Java. It runs on your phones. It runs on pretty much any device out there. Java is just a universal language. JavaScript similarly is a universal scripting language. It's not a full-on compiled language. So up until recently, you weren't writing full programs with it. But it was developed 22 years ago now by Brendan Eich, and it was initially called Mocha. Then it was LiveScript, and it started around the days of Netscape. So back in the 90s, there were maybe 40 or 50 different scripting languages that your browser could use, believe it or not. JavaScript was just one of many. Microsoft put out JScript. Back in the 90s, Microsoft used to buy something or copy what it did. So instead of calling it JavaScript, they called it JScript. It was pretty popular. The thing about this language back in the day was you could send a file to your friend's machine who was on the same block as you and print something. You could open up your CD-ROM drive, if you guys remember what a CD-ROM used to be. JavaScript was really powerful, but the problem with the web is that you don't really want to be able to access opening up a CD-ROM. So a lot of these scripting languages did so much, but they were really insecure. You might still work in an institution that's running Windows XP, hopefully not XP, but a machine from the early 2000s that ran a lot of these different scripting languages that over the years we found out they had too much access to hardware. So here we go. JavaScript has nothing to do with Java. Like I said, it started off being called Mocha, and here's a shot of friends in Central Park. Coffee culture is huge today. It became really, really big in the 90s. That's when it started. Everything was called Java, Mocha, CoffeeScript, Cafe. It was just the trendy thing to do, especially on the West Coast where a lot of the Silicon Valley types live. So what is JavaScript? What does it do? How does it differentiate from all these other languages? Why is it not Java? Java runs a full program. JavaScript runs on your machine. So it's not running on Facebook servers. It's not running in the cloud. It can, but the way we're going to learn it is it's running in a browser. You can't just open a JavaScript file on your desktop and see what it does. You have to open it up through a browser, and the browser will interpret it. So, like I was saying earlier, a lot of programming languages used to be, or scripting languages used to be able to control things like your speaker volume, your CD-ROM, move your mouse around. Imagine how scary that would have been if someone attacked your machine doing all those things. So JavaScript was really designed to have a lot of limited programming functionality and just basically concentrate on those small logical and mathematical instruction sets. Recently, JavaScript has just exploded though, and people are pushing it very far because it can do a lot of things and a lot of people have learned it. So that brings me to why it's so popular. One of the reasons was you don't have to serve up the whole page to a machine. So imagine you're scrolling through Facebook. You don't have to reload that page like we used to 10 years ago when you get to the bottom of the page. It just adds content onto it. So that's less memory, less information coming from Facebook servers to your machine. JavaScript lets you just load little chunks of information everywhere. That was huge. That was called Ajax, if anyone's heard of Ajax. HTML and CSS, they made the web kind of look like word processing on steroids, and now it's just gone completely to the point where we can have Doom and Wolfenstein and 3D games in our browser. So the popularity of all of these things came together, and JavaScript kind of won out because of its high open sourceness and levels of security. So I just want to give a point now here to HTML, CSS, and JavaScript. You guys are all in either the web development stream or the web design stream. So how do these three things talk to each other? Well, I like to think of it like a person. Let me sketch this out for you. All right, here's trusty paint. Here is a person. My little stick figure person. All right, there they are. Okay, let's do this again. All right, so I've got Microsoft Paint open, and I'm going to draw you how I like to interpret this idea of CSS, HTML, and JavaScript. So we'll draw a little person. Here they are. We'll give them hands and eyes and feet. So this person has an eye. The purpose of the eye is to see. The purpose of the hand is to pick things up. You don't ever really change the purpose of what each body part does. So I like to think of HTML like that because a paragraph tag means there's a paragraph there. Paragraph tag doesn't mean you're going to click on something. That's what a link tag is for. So I like to think of HTML as the skeleton and the structure of a person's body. Now, let's think about CSS. Say you're going to go for a run today. You'll put on some shorts, maybe a tank top, because that's what the situation calls for. That doesn't change what your hand does. It doesn't change what your feet do. So CSS is like your style, cascading style sheets. Maybe you're going out to a formal dinner later tonight, so you put on a dress, right? Your style's changed. Maybe you want some sleeves on your blouse or your shirt there. Your style's changed. Your skeleton hasn't. Your feet still make you move. Your hands still pick things up. Your eyes still let you see. Now JavaScript, though, that's your behavior. How do I interact with you? How do you interact with me? JavaScript is all about that behavior. So say we're feeling kind of cool, everything's going well. We'll give ourselves a smiley face. You're interacting with the world. Doesn't matter what you're wearing. But you don't really end up talking to anyone. You see some people from high school that you didn't want to talk to. Let's say that becomes a worse off day. So JavaScript, again, your behavior. Doesn't change your style, doesn't change what your hands and your eyes do. JavaScript is your personality and your behavior, right? It does a little bit of thinking. It's going beyond the surface. That's how I like to think about these three things. So HTML is the meaning and the structure of that meaning. CSS is the style, which can change, doesn't depend on HTML. JavaScript is how you present yourself, your personality, right? You might hunch over or stand up straight. That's your personality. JavaScript can change how everything reacts. It doesn't change what it does, though. Your spine is still your spine. Thanks for putting up with my little stick drawing there. Okay, so JavaScript, while we're still talking about it, one of the things that you should know is it's called JS for short. You'll see this all over the place. Even the logo on the website we're using has JS. It's the language of the web. It works in browsers. That's what we really need to know for this course. But if you're a designer, you've done video work, you work on Unity games, you work in 3D, you can use JavaScript to script, to actually control things like the rotation of a block in After Effects, or go into Photoshop, figure out how many pixels wide an image is, and maybe make it darker or make it lighter based on that. JavaScript can be used with a lot of other programs. For this course, we're still going to learn basics that could be applied to those programs, but we're not learning anything specific to those programs. We're learning for the web. Here's Ben again. What about jQuery? You may have heard of this. JSON, JSLint, JSMin, Node.js. All these different JavaScript things. React, that's huge these days. These are all libraries based on JavaScript. We're not going to learn them in this course. The next course you take, if you stick with the development stream, you're going to be learning them. But what they are mainly is, imagine you know English, you have to learn English, and then you've got an encyclopedia, a library behind you of books. jQuery, JSON, JSLint, JSMin, Node.js, these are all those encyclopedias. They're ways to look up something, to find out how to do new things, maybe how to load dynamic content on Facebook, or like I was saying earlier, maybe learn a JavaScript library for Photoshop, so learn how to use JavaScript with Photoshop. These things go much beyond the basics, which we're going to be learning here. So we're not learning these in this course. It probably will be a little too overwhelming, but I do want to show you what you would learn in the next course if you take it. So let me open up a few little examples here. Okay, so we're back in Chrome. I want to show you a few examples of what you would do in the next course. So when I teach it, we use jQuery. Here's an example of one of the assignments. You make a little whack-a-mole game. So I can click, or, oh god, I'm not fast enough. There we go. There we go. I'm trying to click on the moles that are coming up at random. Oh, there we go. And you'll see at the top left here, it's counting my hits and my misses. Right, there's a bunch of misses. This is all written with JavaScript, HTML, and CSS, mainly JavaScript. Once you're done this course, this assignment is week 2 of the next course. So things become really fun and really interesting in the next course as well. But you do need to learn the basics. A couple other things in that next course. Here's something JavaScript can do. Right, we'll make another game where you try and match things. If they don't match, they disappear. We also make a little bit of a to-do app in that course. So you can say, hello there, or remember the milk, excuse my typing there, and you can delete things as you go. All these things are done in JavaScript. So we're finally here. Let's get to what JavaScript looks like. This is it. If you consider Ben Affleck an actor, then JavaScript does too. We're going to learn what this means by the end of today's course, by the end of today's lecture rather, but this is what you're going to be working with. This is kind of what you're going to be seeing. How do we add this to HTML? Well, we use the script tag. You're going to see in any HTML page, we can write script type equals text/JavaScript. There's some JavaScript statements and then the script tag. So whenever the browser sees this script tag in HTML, it's going to say, I'm not doing layout, I'm not just sending something to the screen, I'm not thinking about meaning or style, I'm thinking about personality and behavior. Here we go. This is going to be our first written JavaScript file, which is actually going to be an HTML file. You've got the slide. I'm going to have a link to this in the lecture notes as well. Let's go ahead, type all of this out. So pause the video, write it out, and make sure you're writing this in Notepad++ or in Sublime. It's going to trip you up if you don't, especially at the quotation marks, and we'll see that later. So go ahead, hit pause, and we'll be right back with this. Okay, so now we've written out all of our code. So I've got mine on the screen in Notepad++. Let's take a quick look at what's happening. We've got our HTML written. We've got our head tag, our title tag, and our head tag. That's all HTML. Now you know everything goes to the browser window is written in your body tag. So we've got an H1 title, and then we've got our new script tag. So I've written it here, and I just want to show you guys that you can highlight things like the whole body tag and hit the tab key, and it'll indent everything for you. So I'll highlight our title. Oops. And I'll bring our bodies in. Our head also needs to go in our H1 and our script tag, and then I'll take the document in a bit like that. So make sure your tabbing is looking like this. This is going to make it a lot easier for us to see. You'll also notice we've got numbers on the left-hand side here. They're going to be useful when you guys are asking me questions, and you're going to say, what's going on in my code on line 7? I can copy and paste it into my program and see line 7. Next thing we need to do is save this. We're going to save it as an HTML file. So file, save as, I'll put it on my desktop, and I'm going to call this hello underscore world.html. Notice that it wants to save it first as a text file. We want to save it as .html. Now, we can go to the desktop. Here's my little hello world. I'll open up Chrome. Let me get out of these slides for a minute. I'll open up Chrome, and I'm going to drag and drop hello world into the browser. And there we go. My first script, hello World Wide Web. So that's our greeting. We've put it in there. I'll break down what this does in a little bit for you, but I want to make sure that you are seeing this. So I'll put both things up on screen. On the left-hand side, we've got the code that we've written together. Let me make that a little bigger. And on the right-hand side, we've got the browser window. So you should be opening up helloworld.html and seeing on the right-hand side, Hello World Wide Web. If you aren't and you can't figure out why you aren't, you can always send me a screenshot, tell me this is what I've done, send me the file you created, and I'll help you see what we've got from there. But you've done it. You've written your first one. Your first scripting programming language, kind of, you're saying hello world. All right. So now that you've written this out, you've scripted it, you're writing your first JavaScript, let's write something else. Now make sure we're inside of these two quotation marks and say, oops, let me put that double quotation mark back, hello mom. I'm going to save this file. So I'm saving over the original, and on the right hand side I'm going to hit refresh, and we'll see hello mom came up. So for the first 2 weeks we're really going to get into this process of writing a file, saving it, bringing it into the browser and seeing what it does. So JavaScript exists inside of HTML. Let's take a look again at what's happening. We've got an opening tag here, our script tag. Now in HTML, we sometimes can write things like class equals, maybe it's alert. We can write ID equals first title, something like that. These are what we call attributes in HTML. Now the script tag, it is HTML, it also has an attribute, and that's this right here, type equals text/JavaScript. So make sure you have that in your script tag. You actually don't absolutely need it, but it's a good practice to have it in there. Now in between our opening tag and closing tag, we've got the code. In this case, we're just going to go with it, document.write, meaning document.write, open a bracket, close a bracket, and put two quotation marks around what we want to go to the screen. That'll be our kind of what we call a print screen.
It'll put something onto the browser window. And we follow it up with a semicolon. So let's write another piece of code. Document.write. I like to open my brackets and close them at the same time. You'll find your program might do that for you. We're going to end it with a semicolon. And then we'll say, goodbye world. Hello world, goodbye world. That's kind of depressing. Let's do instead, hello mom, hello sister. I don't know why I'm capitalizing sister, but I am. We can save this, file save. Go to our window here, refresh it, and there we go. Hello mom, hello sister. The first thing you're going to notice is these are on two different lines. However, here, hello mom and hello sister aren't on two different lines. Well, why is that? It's because document.write is a built-in function of JavaScript to send whatever you put between two quotation marks up into the browser window. It can also put in HTML tags. So there we go, a break. I'll put a break in, save that, hit refresh on the right, and we'll see we've got hello mom, new line, hello sister. It actually took that HTML right here and it put it to the screen, and the screen interpreted it as HTML. Now the fun thing to note here is if you right click and do view source, view page source, you'll notice we see the JavaScript here. We don't actually see hello mom and hello sister as HTML. But if we use the inspector, which you may know, but you might not, you can see what the page looks like once it's been interpreted. Once the browsers run JavaScript, this is what it will look like. We'll right click on the page, hit inspect, and you can hit one of these toggles. We'll click the body tag. Here you'll see hello mom, followed by the break tag, followed by hello sister. So JavaScript, this piece of code right here, created these little words, hello mom and hello sister, on the page. Something to know, again, you don't have to memorize this at all, but you're going to be getting familiar with all these tools. I'm just throwing you right in right now. So what exactly is happening here? Let's find out. Let's go back now to our slides, and you'll see what I've written. Hello world is up there. We see our HTML tags. Script language text equals JavaScript is an opening HTML tag, and that slash script is the closing tag. Everything in between is JavaScript, and we can write as many lines of it as we want. You can write hello world 10, 20, 30, 40, 50. It'll probably take you until 10,000 or so times until your browser has trouble with it. You'll see in the slides I've also written out what we just did. Hello, how are you? Hello, how are you, with a break. And now let's start understanding what we've actually done. So the way JavaScript works, just like that peanut butter and jelly sandwich, is it writes a statement as an instruction. So every time there's an instruction, for JavaScript to know this is the end of the instruction, let's move on to the next one, we have a semicolon. So statement 1 is a semicolon, statement 2 as a semicolon. Every time you write anything with a semicolon, we call that a statement. So here's an example. Document.write, hello World Wide Web. We could write that out in our script tag. That's one statement. Now underneath it, we've got 3 statements. They're each a piece of HTML, and together we call a bunch of statements that we put run after another a block. It's not a definition term in that if you have 10 lines and then 2 lines or 3 lines, you need each line to be separated into a certain number. It's just a way to think of like a paragraph, like you're stringing words together. These statements kind of do the same thing. Let's put them together because they make a peanut butter jelly sandwich. Maybe you're getting milk afterwards. You'd put those all together as a statement block. So peanut butter jelly sandwich, statement block, getting milk, statement block. Now all this computer code is sometimes hard to read, so it's good to make comments to ourselves. If you know HTML, you know you can write comments. It's a piece of information the computer just ignores, but that a developer like you, like me, who's coming to the code or revisiting their code, can look at and understand and know that the computer doesn't care what it means, but it's plain English. Kind of give yourself some meaning behind what you're doing.
So why do you want to do this? Maybe you think of it like a sticky note or writing notes on a textbook. How do we write a comment? 2 forward slashes will tell JavaScript, ignore this. If you have more than one line, you have to tell JavaScript /*, put your lines in, */ So let's go back to the piece of code we already have. Here we go. Hello mom, hello sister. I'll write another piece of code here. Document.write hello father. Hello mother, hello father. Isn't that the song? I'll give this a break tag. Bring down a line, and my cursor's right here at the top. I'll do // and I'll say, I'd like to say hi to my family. Plain English. JavaScript says 2 slashes, I'm ignoring this. Let the human speak to the human. Let them write whatever they want. I'll just move on to the next line where I'm told to do something. And here's a statement. So notice comments don't end in semicolons. They don't need to. Now if I want to write a note to myself to say, okay, I've got to remember to say hi to all of my extended family, I'll do a multi-line comment. Remember to say hi to all of your extended family on both sides of the clans. And I end it with an asterisk and another /. There's my multi-line comment. So I'm going to save this again by hitting save. Go back to the browser window. Hit refresh. There we see hello mom, hello sister, hello father. We don't see the comments. JavaScript doesn't care what they say. Now if I get rid of these slashes, JavaScript is not going to know what to do. Let me go refresh that page. It broke. Now there's a syntax error for you. When JavaScript breaks, it just gives up. It doesn't always tell you why it gave up. It doesn't tell you where it gave up. It just gives up. So it's going to be on you to look at your code and figure out what's happening. Maybe I've done something like incorrectly written this. Documentate hello sister. So I'll save that. I'll refresh my page. I got to hello mom. So I can think to myself, okay, something must be wrong after hello mom, because we know that JavaScript reads things from top to bottom. So it started at the top and it got something. What you might do at that point is use comments to help you troubleshoot. So you might say, I don't see, there might be a typo somewhere, I don't see what the error is. Let me try commenting out a line. So I'll comment out line 11, hit save, hit refresh, did nothing. Well, I'll try commenting out line 10. I'll hit save and refresh. Everything's fine. The only thing that's working is hello mom. Well, what if I bring hello father back into it? Hey look, that worked. So I've got a problem with hello sister. Now I look very carefully, and you know what guys, this can take a long time. You might be searching and staring at your screen, not seeing the fact that you mistyped something. You have a syntax error. It takes a lot of time to see. Sometimes you might just want to get up from your screen, get a glass of water, go sit down, and look, document, go through line by line, see where your typo might be. Sometimes you might want to just retype it, and then you'll say, hey, I don't know what I typed wrong, I didn't see it, I retyped it, I must have done it right. So hello sister. I'll save that, and there we go. So comments can be used for making notes to ourselves, and also for helping us troubleshoot by commenting out code, telling JavaScript, ignore this line of code for now. Okay, let's now take a look at how we actually can start to do more than just print something to the screen. Computers can remember stuff, right? We can save a file. We can write to-dos on a to-do list. Let's actually use that power. Now, that's what computers were originally built to do. Compute things, remember things, work on something, and then be done. So the best way to think about this kind of paradigm, at least in my opinion, is to think of these empty jars. When your computer has gigabytes of free memory, it just has tons and tons and tons of empty jars. So the way it remembers things is by creating a variable. You may have heard of variables from arithmetic or math class. It's really similar in that variables just are a placeholder with a name for a value. Variables remember things. So you can imagine, okay, I have to buy 5 apples at the store today. I need to put this down somewhere so I can remember it. What a computer does is it takes one of those jars, puts the value in, okay, I need 5 apples, so I'll take that number 5, put it in the jar. I'll label that jar. I'll say this jar is called apples, and then I'll tell it this is a number. Remember this number. So really a variable does a few things. It takes a label, it takes a value, and then has a type of that value. So name, value, and type. That's what you can think of with a variable. So in this case, we need 5 apples. We slap the label apples on, put the number 5 inside, and now we've got a jar among all these other empty jars that says apples on it. Now you can only have one jar that says apples on it. So a variable can only have one name. So let's kind of write this out in JavaScript. How would we do the same type of thing? The first thing we do is we declare a variable apples. We give it a number, and then we can grab that variable. So here we go, we say computer, grab that variable. It looks through the buckets or through the jars until it sees the label apples. There's the number 5, it grabs the number 5, and it can print it to the screen. So let's write out what I just said in JavaScript together. Open up your Notepad file, and we'll add to it. I've got our file open again with our document to our right. Hello mom, hello sister, hello father. I'm going to save this as hello world. File save as. Clear out all this code. And then give it a new name. We'll say file save as variables intro. Let's write down our comments. This is something I like to do before I start writing the code, giving those instructions just like making that sandwich. So 2 forward slashes. We'll say here we declare a variable called apples. The way we declare a variable is by using a keyword, var. So whenever we want to grab a mason jar that's empty from the computer's memory and put something in it, we first have to give it a label. So first step is giving it a label. Here we're calling it apples. And then this is a statement, and like we know, all statements need a semicolon, so var apples. The next thing we'll do is we'll say here we assign a value to apples. I'll go down, write some more comments. I'll say here we can retrieve the value of apples and send it to the screen. So to assign that value, we use something called the assignment operator. It's really just an equal sign. So we take apples, the word we created, and we say equals 5. Semicolon. Never forget your semicolon, guys. It's going to be one of those things you just have to remember. Semicolon at the end of all your commands. So what we've done is we've said, take the jar, slap the label apples onto it. Apples now has a value of 5. Now, if we want to retrieve that value, we can use document.write, like we've done before. Open up our bracket, close the bracket, hit our semicolon at the end, and this time, instead of putting in, say, the number 5 in quotations, also get rid of those quotation marks, just have those back brackets, and type in the word apples. This will retrieve the value that we've set up here. I'm going to go ahead and save this and come back to Chrome and open the file. Let's open it this way. Here it is, variables. Let me try that again. Too many windows open. Now I'm on the desktop. I'll grab variables intro, drag it to Chrome, and there we can see the number 5. let's go back to our Notepad file. Just rearrange it here so you guys can see everything as I'm working on it. You know what? I'm going to make this a multi-line comment just for the sake of you being able to read it on the screen at a bigger font size. There we go. What if we want to now change the value in that mason jar? Say change the value of the variable apples. Maybe I really only need 4 apples today. I can write apples equals 4. What that's doing is telling the computer, go to that jar, grab apples, whatever value's in there, just replace it. Now I'll write the new value to the screen. Document.write apples, just like we had before. I'll save it, and before I run it, I want you to take note. Document.write apples will send the number 5 to the screen because apples was equal to 5. Remember, this is linear. This command comes first, then this command, then this command. Once we get to this line 16 here, apples is equal to 4. The computer will already have sent 5 to the screen. So we'll see 5 on the screen, then it will change, then it will send a 4 to the screen because apples is now equal to 4 once it gets here. So I can save that, come over to Chrome, hit refresh, and there we go, 5 and 4. So at one point in the program, apples was equal to 5 and we put it to the screen. We changed that value, and as the program kept running, it then wrote out the number 4. So variables can change. Now I'm going to make a second variable up here. Var oranges. Right, apples and oranges. I like to declare my variables together, just for the sake of keeping things organized. Down here, before we change the value of apples to 4, I'm going to say set oranges value to the value of apples. And I can do this by saying oranges, go get that jar of oranges. Right now it's empty because we haven't given it a value. I'll use the assignment operator, the equal sign, and I'm going to give it the value of apples. Well, what's the value of apples right now? Let's look. Apples has nothing, oranges has nothing. Let's give apples a value of 5. Let's send the value of apples to the screen. Let's give oranges a value of apples. Well, apples right now has a value of 5. So oranges is going to be equal to 5 as this piece of the program runs. Apples will then equal 4, and we'll write apples to the screen. Now if I want to write the value of oranges to the screen, I can use document.write again. I can use the variable name oranges, and I'll send that to the screen. Now oranges is equal to the value of apples at this point. It's not equal to whatever value apples is later in the program. Oranges just took the value of 5. Apples was replaced with the number 4, but oranges wasn't. Oranges, again, here on line 17, just took the value. So oranges will show up as 5. So we should see 5, 4, and 5. 5, 5 here, 4 here, and 5 here. So I'll save this just to prove that to be the case. And there we go, 5, 4, 5. So one more time, oranges is given the value of apples at this moment that the program ran. It is not going to always be equal to whatever apples is equal to. So just to review that again, every variable has a value, a name, and a type. So now we've seen how to use and declare and initialize variables. We declare a variable as an empty memory space. just like a jar, by giving it a name. Then we put a value inside and we initialize it. So we declare, then we initialize it. var space name semicolon. And then we give it a value by reusing that name, putting the equal sign and a value behind it. Now the idea of the variable having a type has to do with the value we put in it. We can either put in a number type or a phrase. We're going to call phrases strings. Let's open up a new file and take a quick look again at numbers. I'm going to say var first number, var second number, var third number. And then I'm going to write all these to the screen in a moment. And we're going to see the variations where you can have with numbers. So for our first number, we're going to give it a value. Let's say this is my age, 32. That's a whole number. We're going to call it an integer. Just like in math, you call whole numbers integers. Our second number, let's imagine this is a dollar amount. We'll say 1085. That's a decimal. We call that a float. So I'm going to put a comment after the statement here saying 32 is an integer, a type of number. I'll make this a little bigger for you guys to see. And here we'll say 1082 is a float, a type of number with a decimal point. And our third number is going to be negative 252.85. You can imagine that's a balance. Negative 252.85 is a negative number. I'll put in the values, 32, or not 32, I'm going to put in first number. I'll put in the values second number. And the value of third number here. Numbers can only be represented by the digits 0 through 10, 0 through 9 rather, 0 through 9, a decimal point, or a negative hyphen. Those are the only things we can put in. So if I went and took first number, well, let's send it to the screen first. I'll open this up in Chrome. You guys should be used to this by now. You should be doing this pretty snappily. Let me open up my desktop. So I've called this one value types. Here we go. Oh, it was open. We'll see at first we get 32. Followed by 1085, followed by negative 252.85. When I'm looking at these numbers, I said 32 was my age. Okay, I can understand 32 being age. Second number, 1085, that could be a monetary value. Negative 252, maybe that's a temperature. So I might want to say 32 years old, and I might be tempted to say 1085, and I might be tempted to say here Celsius, but watch what happens. Nothing works. That's because numbers can't have anything but 0 to 9, a decimal point, or a hyphen. Even though it's tempting to add the units in there, we won't want to do it because JavaScript thinks of numbers just as pure numerical values. So we have floats, we have integers, and they both are number types. The other type we can have, and I'm going to write this down here, is string types. You can think of a string as a phrase. We've already used hello world, hello world wide web, hello mother, hello father, hello sister. We put all of that to the screen already. And you may have noticed that whenever I was writing out words, and by words I'm really just saying characters from A to Z, I was putting them in quotation marks. So when you put them in quotation marks, that makes them a string. A nice way I like to think of this, to remember what the word string means, is those happy birthday banners or Merry Christmas, Happy Hanukkah banners. They're all letters put together with a string. So you can imagine that strings are just characters put together. So I'm going to say var first string, var second string. We don't need too many of these because they're not too complicated. I'll do 3 examples for you here. Var 3 string, I should say third string. And we'll write them all to the screen. Document.write. I like setting this up in advance, and I'm even going to copy and paste these just because it's so simple. So first string, and when you're in Sublime and Notepad++, you may have noticed if you've already declared a variable, you'll have them listed out down here as you're typing. So you're able to just go pick it and hit enter. I used my cursor key to do that. Second number as I'm typing it, I can hit enter. And third number as I'm typing it, I can hit enter. So now let's give some string values to our variables. Assign string values to our variables. First string. Now what we saw was hello world. Notice that everything within these quotation marks is going to represent our string. So here I'll say hello world. In my second string, I'm going to show you the alternate way to create a string, and that's by using single quotes. Hello, Mars. We're going to be in Mars soon, right? And finally, for my third string, I'm going to show you why these don't mix. I'm going to use double quotes and say, Mary said, and I'll quote Mary here, totally rad, period, and I'll end my statement with a semicolon. You'll notice that already we can see totally rad just by the color doesn't look like it's part of the string. Same thing would hold true if I make a fourth string. Let me come down here. Var fourth string. Fourth string is equal to I can't come to the phone. So everything inside a string can be any symbol, any letter you want, except for quotation marks that are used on the outside of the string. And what I mean by that again is that if I'm using double quotation marks around hello world, well, I can't put a double quotation mark inside of hello world. If I'm using single quotation marks around hello Mars, I can't put single quotation marks inside of hello Mars. And we see that looks like it's breaking here. So if I send all of these to the screen, I misspelled fourth here, cut and paste that. Fourth string. Something's broken. Now if I comment out these lines here, the two offenders, and I comment out third and fourth string because they don't have a value, because I commented them out here, everything should run again. There we go. So hello world works. I didn't write hello Mars. Ah, see, I wrote second number down here. I should have done second string. And I'll save that and see it there. So I don't mind showing you guys my mistakes when I do that. I put the wrong variable name somewhere because at this point, I'm sure you've paused this recording a few times, looked at your own code and said, why doesn't it match to his? What's going on? What's the difference? This is all normal. Even a seasoned programmer who's been doing this for 15 years of his life is constantly writing the wrong thing and just realizing that I wrote it. The nice thing is you can always revise it. There's no final answer. You're not publishing this. You're just playing around. That's why I like to call this kind of a sandbox or a playground. Okay, so first string, second string, we saw hello world, hello Mars, go to the screen. And like I said, third string and fourth string, they're just breaking the whole thing because strings have to be enclosed with an opening double bracket and a closing double bracket, or an opening single bracket and a closing single bracket. you can't have a combination either. So if Mary said shows up like that, and down here I open, okay. So here I open with a double quote, I close with a single, and here I open with a single and close with a double. Again, this should break our program. I'll hit save there. Come over here, refresh, and again, it's still broken. There is a way, though. You might be thinking, what if I need to put an apostrophe and a quotation mark in a sentence? There is a way, and we call that using the escape character. So, Mary said, what did she say? Go home. I think that's what I had her say. And I can't come to the phone right now. We can use what we call the escape character. And that's just a backslash. We put a backslash before any quotation mark that we want inside of the string. So watch, we'll go from black on go home to gray, just by putting the backslash in. And we'll need one here as well. And down here on I can't come to the phone, we'll need a backslash as well. So there's our escape character. I'll write a little comment here. / for comment, escape, the double quotes. And down here I'll say, let me move this over for you to see. Escape, single quotes. I'll save that up. We'll send it to the screen, and here we can see, yep, our single quotes came through. And Mary said go home. I didn't write that to the screen. I had the same error I had a moment ago. Third number should be third string, so not really an error, just me not paying attention. So save that, I'll refresh, there we go. Mary said go home, and I can't come to the phone. Both of them are going through because of our escape character. So now you're already thinking, well, how do I put a backslash in there? Say we want to do a little emoji. I'll make fifth string, var fifth string. Let me scroll down a little bit so you guys can see everything we're doing with strings here. Fifth string. And you know, there's that emoji, the shrug emoji. I believe it's dash, backslash, lower score there, and two little eyeballs, an underscore there, and a /. There we go. That's the little emoji. I'll send this to the screen, document.write, fifth string. I'll save this, hit refresh, and notice how our emoji doesn't show the backslash. That's because it's the escape character. Well, the way to show that backslash is to escape the escape character. So 2 backslashes. We can save that, hit refresh, and there we go. We can see 1 backslash appearing. So we've seen that strings need to be surrounded by either double quotation marks or single quotation marks. And if we need to show a special character like a double quotation mark or a single quotation mark inside of a string that's already using them on the outside, well, we use the backslash to escape that character. Now, one other thing to watch out for. I really want you guys writing all of this in Notepad or Sublime, because if you copy and paste from the web, or if you write it out in InDesign or Word, you're going to have quotation marks show up as curly quotation marks. I'm going to open up Word and show you what I mean to avoid. Let me go ahead here and say var 6th string. First of all, Word capitalizes, that's not very good. But I'll say 6th string is equal to quotation mark hello. Let me zoom in so we can really see what's happening. Word tends to add curly quotes every time you use a quotation mark. Same thing goes for hello, I can't come to the phone. Notice how this single quotation mark here again is more of an apostrophe. So if I take this code, copy and paste it into Notepad, this is 5th string, So I'm just literally copying and pasting it from Notepad. And then I'll move 6th string, this guy. I'll move it up here. Just so all my variable initializers are at the top. Notice how the double quotes, I'll zoom in really far for this one. Notice how the double quotes look different. That's because Word handles quotation marks and apostrophes differently. That holds true if you copy and paste out of the browser. That's why we want to always be dealing with a text editor, because as I save this, you'll see again, it breaks the program. Now, one final thing, if you're thinking this is kind of messy at this point, because we've written so much, I'll comment this out. If you want this file to appear a little more organized for yourself, every time we do document write, you might want to write an HTML break sign. Every time after a command. That's because it'll just send everything down to the next line. So I'm going to copy and paste this line. And bring it over. And I'm going to add it in. Now, using document.write this way isn't ideally the way you'll do it once we reach week 7, but right now it's just a tool for learning. That's why this can look a little overwhelming. Oh, and I put it in the wrong place again. See? I can't seem to talk and type at the same time. Let me put it in here. So document.write, my break tag, another break tag, and another break tag. I'll save this up, and I'm going to be posting all these scripts for you guys to look at. So there we go, and you can see I missed one, hello world. So I guess right after this guy, after third number, I'll put one as well. So there are our different types. We've got numbers, which can come as decimal floats, or as full integers, or as negative values. And then we've got strings, which can be surrounded by quotation marks, or double quotation marks, or single quotation marks. And those are the value types we're going to be using for week 1. The only thing left to do now is start calculating and playing with all these values, and then I'll be setting you up with homework. So I'm going to set this up as the next step. If you want to take a break, this would be a great time, and we'll come back and talk about equations and calculations. All right, we're back from break, if you took one. Otherwise, it's just been a few seconds, but I just grabbed some water to refresh my voice, and we're going to talk about JavaScript operators. That's pretty much thinking about how we add numbers, subtract them, divide them, multiply them, and do other mathematical functions to them. What I'd like you to do is recreate a new HTML page. You can pause the video for a second, and I call this one JavaScript_operators, and I've got a bit of a clean slate here. So we've got a script tag, title is operators. Let's go ahead and start figuring out a few different operators that we can use. I'm actually just going to show you these on the slides that I created from current slide. Okay. Here we go. Here are the operators that we can use. You'll notice most of these should be familiar to you. Use them in a calculator. We can add two numbers together. They can be integers or floats. So here we go, 5 plus 4.3. 6 minus 11. 6 times 7. Now notice for multiplication we do not use an x. We use an asterisk. That's shift 8. There's division, 3 divided by 7. And then there's something here called modulo division, which you'll rarely use, but it just gives you the remainder of a division. So if you divide 23 by 6, 6 goes into 23 18 3 times, you're left with 5. You'll get the result of 5 for that one. And we'll try these out in a little bit. Also remember BEDMAS from mathematics in high school. Brackets, exponents, division, multiplication, addition, subtraction. So order of operations really matters here. We can see if we did 5 times 5 plus 5, that would give us 30. But 5 times 10, which is 5 plus 5 in brackets, would give us 50. So it'll give us a different result. So remember, you can use brackets here just like you would have done in math. This isn't a mathematics course. We're just harnessing the power of JavaScript So I really don't want you guys who fear math to be overwhelmed by this by any means. So let's try out some simple calculations. We're going to write this together, and I'd like you guys to kind of fill in the blanks as we go. So I've got a bunch of comments going. I'm going to put this in a file on the website, so I want you to follow along with me and fill it out. Open up a new Notepad file, put your HTML code, grab this from the website if you'd like, the starter code, or go ahead and type it all out. So I'll give you a second if you want to pause the video to do that now. So here we have the starter code for exercise 1 on the left, and I've got it open in Chrome. By this point, you guys should be really familiar with opening a file, saving it, bringing it into Chrome, making changes on your file, then refreshing it in Chrome as you go. So if you've read through this, you'll see there's a lot of comments. I've initialized a variable here for you, var current year, and I'm asking you to assign a number to that current year. So what year is it right now? Well, we're in 2017. So current year is equal to 2017. Then I'm saying use document write to calculate how many years since you graduated high school. So I've got this done for you. Document.write current year minus 2003. Right? That's our operator. If we go back to the slides, we can see subtraction is just that hyphen. So that should write our age to the screen. Let's refresh the page and make sure that happened. It didn't happen. Let me just double check what I've been doing. Current year is 2017, document.write. I'll save that file and refresh it. Still not happening. Ah, right here is my error. I don't know if you guys saw that. In my code, I'll make sure this doesn't make it to the website. I copied and pasted, like I told you guys not to. That should be a double quotation mark. Let's save that, refresh. There we go, 14. So 2017 minus, oh sorry, not my age, minus the year I graduated in. So I graduated from high school 14 years ago. Current year minus 2017 is what we're getting. So I want you to calculate when you graduated from high school. You could change 2003, maybe it's 2015, maybe it's 1998, whatever it might be. Now in this next line, let's calculate how many years since you were born. So document.write current year. Now, I was born in 1984, so I'll put that down, and I'll also send that break line to the page. This time I won't mess up my quotation marks. Break. There we go. Make sure my statement ends with a semicolon. So I was born in 2017, 1984. I was born 33 years ago. I'm still 32 though, because I don't turn 33 until later in the year. Watch out, because that's on a question that's coming for you guys for homework. Now, how many years until I can retire at age 65? This is probably the most complex math question we might have. Maybe a little bit more complex. So document.write, let's say current year. So if the year is 2017, I'm 30, it's minus my age. So I'll say 1984 plus 65. I'll be retiring 65 years after 1984 minus the current year. Semicolon. And I'll copy and paste this break, put it down here, and save that. So I'm halfway to retirement. That's quite a long time to live this all over again to get to retirement. That's quite funny to me. All right, let's keep going. I'm asking you to write an equation to convert 100 kilometers, I'll get rid of that, to miles. So if 1 kilometer is equal to 0.62 miles, we just multiply 100 by 0.62. So document.write 100 times 0.62. Document.write break tag. Now you should take a moment as we're going through this. I'll put this one up to the screen. 100 times, so 62 miles is 100 kilometers. At this time, you should just pause this video and fill in the rest of this exercise. There's only really 2 more things to do. Try and figure them out. I'm going to keep going with this, but unpause the video once you have them and you can compare them to what I've been up to. So I'm going to next calculate that if the Earth has a circumference of 40,075 kilometers, what would be the circumference of the Earth in miles? I'll do document.write again. Document.write. Oh, I don't need my quotations. So 11.4 is minimum wage. Now say I work 8 hours a day for 5 days a week for 52 weeks a year. That means I'm just using multiplication here based on minimum wage. So again, minimum wage times 8 hours in a day, 5 work days in a week. Then let's say we work for every week of the year, 52 weeks. Let's put that to the screen. That would be a minimum wage has a salary in Ontario of $23,712. Let's keep going and rewrite that calculation divided by 12 to determine our monthly wage. So document.write, again, 11.4 times 8 times 5 times 52. And I'll send that to the screen. Also write my document.write break tag. Now notice here that if we want to get that wage and convert it to months, we have to divide by 12. Remember bed mass in order of operations. If I divide by 12, just like this, I'm going to get 1976. It would be more ideal if I put brackets around the whole thing and then divide by 12 to keep myself organized. In this case, it didn't matter, 12 months, but I'm trying to think of this as a whole value and then dividing it by 12. So just be careful with your bed mass again. Always just think about it, what calculation should happen when. So that's exercise 1. I'm hoping that this idea of writing things to the screen, saving your file, refreshing in Chrome, is pretty second nature right now. We're going to do a few more exercises and we're going to work with phrases next. Now that we've looked at arithmetic operators, we've got addition, subtraction, multiplication, division, and modulo division, let's look at operators that work on strings. And there's really only one that we're going to be using. And it's called the string operator. It looks like a plus sign. In fact, it is the plus sign. It's the exact same symbol that we were using to add 2 numbers together, and all this does is join up 2 strings. So let's go make a new file. I've got one started right here, string operators 1, and we'll see how this works. Open my file up in Chrome by just typing the file name in. Let me save this. Here we go, string operators 1. Document.write. So we had hello world before, and we're just going to do hello plus world right here. Send that to the screen, and you're going to notice hello world doesn't have a space. That's because JavaScript doesn't have a brain to understand phrases, words, has no spell checking in it. It doesn't understand if you're writing gibberish, Klingon, French, Italian, whatever it might be. So we have to add the space in manually. I'll add a space in right there, hit save, and there's hello world. So remember, with the string operator, really one thing to learn, we can call it concatenation. It brings 2 strings together, and it uses the arithmetic operator, the addition symbol. Same thing as plus. Now you can't use minus, asterisk for multiplication, divide. You can't do that with strings. If you try to do that, you might get the result not a number. Let's try it right now. So hello divided by world, we might get not a number. There it is, NaN, not a number, because it only works on numbers. So again, the operators we've looked at are plus, minus, multiplication, division, modulo division, and then reuse that plus sign to bring two strings together. And that's the string operator, pretty straightforward. So I've put together another file, same way we've done it already. We're following this template. It's just called expressions. Now expressions are a way of using these arithmetic and string operators to give values to your variables. So instead of saying my age equals 32, we can now say my age equals 2017 minus 1984. That's going to give us a bit more flexibility to calculate ages now. Let's start off with some expressions working on numbers. So I'll say var x and var y. I'll say x is equal to 2 plus 2. And there we go, we used our operator. It was as simple as that. Our whole statement is the line. The expression is 2 plus 2. And 2 plus 2 will give us a number value, because it's two numbers we're adding together, and that number value will be applied to x. We can do the same thing with y, and we can even say y is equal to x times 3, where x is equal to 4 at this point in the program. So 4 times 3 is 12. Let's try this out. Document.write x, and then document.write y. Now remember, I've got all these examples in the slides for you guys to look at with a little bit more detailed explanation if you're more of a reader, or if it helps you learn that way a little more. So I'll save this, and we'll refresh the page. We get 4, and then 12. Perfect. Let's keep going and work on some string expressions. This can be a little bit more fun. So var, we'll do first name, var greeting, var formal title, var formal greeting, and we'll add some phrases here. So we'll say first name equals Pamela. Our statement ends with a semicolon. Let's do greeting. Our greeting will be hello, put in our space so that we have something come after it, and we'll say plus name. So greeting should say hello plus, first name, not just name, and that should give us Pamela. Let me write out greeting to the screen. Document.write greeting. Save it. Hit refresh in Chrome. I have an error. Let's see if we can find it. First name is Pamela. Greeting is hello plus first name. My semicolon is in the wrong place. Just a typo. I'll move it to the right. I'll refresh the screen. There we go. Hello, Pamela. And I'll add another one of these breakpoints just so that looks a little bit nicer. Hello, Pamela. All right, let's add a formal title to Pamela. We'll say formal title. We'll give it a value of Your Highness. And then we'll give a formal greeting. So we'll have two types of greetings for Pamela. And this time I use single quotation marks just to change it up. Formal greeting is Your Highness. Your Highness, formal greeting will be greeting, which is hello Pamela, plus formal title. And we'll send the formal greeting to the screen. Formal greeting. Refresh the page. Again, I've got an error. Greeting, I have an extra E. I'll refresh the page again. Hello Pamela, followed by hello Pamela, Your Highness. Need to do two things. I'll break the line here at hello Pamela after the first greeting. And on the second one, like I said just moments ago, we need to add a space because, again, JavaScript doesn't know what a word is. It doesn't know what these words are. So we'll add the space to make it look more human readable. I'll save that up and hit refresh. Hello Pamela, Your Highness. Not sure if I'm supposed to capitalize Your Highness, but I think you guys get the point on this one. So let's take a quick look at all that we've just seen. We put our strings together with concatenation. We just ran these examples here. putting strings together. And if you want, you can stick around and play with this a little bit. So instead of Pamela, you can say, hello, Emilio, your greatness. Send that to the screen, like hello, Emilio, and hello, Emilio, your greatness. So the second I change first name, the nice thing is that it changes in our other places as well. That's what this kind of string arithmetic, string operators helps us do. We write a name once, maybe you've logged into Facebook or Twitter. Every time you log in, you see your name or you see your handle. That's because there's a variable there that uses your name. So Emilio is sleepy. So I get out of bed in the morning and I'm tired. I post. Emilio comes from Facebook, is sleepy. And then later on in the night I post, is looking forward to a night out. It would say Emilio is looking forward to a night out all the time, keeping my name as that variable value. So these things are really powerful as we get to use them. Here's some examples. Again, I'm using Ben Affleck here. You can write this one out on your own. So it's pretty much Ben Affleck trying to assert that he's the best Batman. Try and get this to appear on your screen with proper punctuation. You'll notice that I added spaces in. Try this one out. Maybe you can change the name to Matt Damon. Maybe he wanted to be Batman. You never know. So you can pause the video here, write this one out. It's also in the slides. Here is our exercise number 2. I want you guys to write this code out or copy it from the exercise 2 starter code. Try it out, pause the video. You need to put in some nouns under assigning values to your variables and see what you come up with. I'm going to go fill this out, hit pause. I'm going to do a hard cut here, and then we'll come back with my code written out, and we'll see how yours compares. So hopefully you filled out your variables with some values. I've done that as well. You can see I did 2 nouns, boy, hot, love, and emotion. A place is the 6. Verb 1 is cell phone calling. Verb 2 is want. And I added some of my own punctuation in here. So let's fill out this limerick. I'll run it by going to my desktop and grabbing JavaScript exercise 2. And there we go. There once was a boy from the 6 who had a lot of cell phone calling to do, who'd want a hot love and emotion until his cell phone calling was through. There you go. I'm sure you guys can guess who that little boy was. If you want, go ahead, ask a family member to put some values in here. Tell them, give me a noun or 2 nouns, 2 verbs, a place. See what you come up with. As you can see, this arithmetic of words using the string operator, the plus sign, is really just putting a bunch of words together and poking holes in them with variables and placeholders. So this can be really fun, and a lot of our exercises this week are going to deal with that. Now you have almost all the tools you need to get through week 1. We've got a few more coming, but I just want to take a break and talk about organizing your files out. So thinking about variables, we've seen how they're kind of name storage spots. When we're talking about organizing our code, you've seen me do this. I like to declare the variable names var space variable name at the top of the file and then give it values at the bottom. It's a convention that will keep a lot of your code organized. This is kind of the way that we organize our programs when possible. We write all of our variable declarations at the top and then we work with them later. So like we talked about the peanut butter and jelly sandwich right at the beginning of today's lecture, we went and got all our ingredients and then we acted on those ingredients. You can think of it that way if you'd like. So when I'm marking your assignments this week, I really don't mind if something doesn't work. I'm looking at the code you've written. I'll be looking if you've added comments. I'll be looking if you've done your variable declarations. And I'll really also be looking to see that you have your variables declared at the top, that you've told me in comments what your variables are supposed to do. And then your programming statements, your operations, your arithmetic or string operations come at the bottom. So we really want to keep organized. Now there's something else to understand here with variables. We've got a couple things to think of. You can change the value of a variable whenever you want. I've shown you that today, and you can change between a string and a number whenever you want. You don't have to commit one variable being a string all the time. Emilio, first name here, could be equal to 3. Doesn't make sense to, so you probably don't want to, but it could be if you'd like to. When we're naming our variables, you've noticed that have been, for the most part, pretty specific. If I'm talking about a name, I'll go with first name or last name. Or age, I'll talk about my age. There are a few rules, again, that you don't have to stick to, but I'm going to dock marks if you don't stick to. on picking your variable names. Now, the first rule of thumb is be as specific as possible. Don't just call a variable dog, call it my dog or neighbor's dog, dog 1, dog 2, dog 3. Try and be specific with your variables and so much as what they hold. So when we're naming these variables, there are some rules you have to stick to. You have to start your variable name with a letter, the $, or an underscore. You can't start your variable with 1 dog, 2 dog. JavaScript will break if it sees that. Rule of thumb, always start with letters. Variables can only contain letters, numbers, $, and underscore. They can't contain exclamation marks, quotation marks, digits, or anything of that nature. Variable names are case sensitive. So always capitalize consistently, and I'm coming to a rule to help you out with that in a moment. Next, really important thing is avoid reserved words. So I'm going to click on reserved words. This is right from the slide deck, so you can see this. Here are reserved words I'm showing you online. This is Mozilla, the guys that make Firefox. This is their documentation of JavaScript. They've got some great stuff out there for developers. Here are some reserved words. Here are all the reserved words. Break. So you can't call a variable break. You can't call a variable function or return. You can't call a variable double or volatile or throws. These are all reserved words. And some of them you're going to run into. You might accidentally use them. Try to avoid them if you can. Now, the best way to avoid them, in my opinion, is to use 2 names for something. So instead of just writing age, year, location, distance, try and write current age, previous year, option X, total distance, username. If you kind of have an adjective and a noun together, you're not going to run into hitting a reserved word. It will just keep it safe, less chances of your code breaking or JavaScript just not understanding. That's what happens when it breaks. I said when you were naming your variables, you're going to run into the idea that capitals really matter. So here we can see my variable, my variable, my variable, and my variable. They're all capitalized differently. They're all different labels. JavaScript will not see these as the same variable. This last option, my variable with capital V, is the proper way to write a variable name in JavaScript. So you start your first word with a lowercase letter, and then you go on to an uppercase letter. This brings us to our third exercise for the day. I want you to add a bunch of named variables, based on all these different criteria I have for these bullet points. So a variable to hold your weight, describe your birth city, to describe any location, to represent the value 3.14, variable to represent a dog name and another dog name, so 2 variables right there, declare a variable to represent the current year, and declare one to represent your age. I then want you to give values to these variables once you've declared them. Now that's not all for exercise 3. Once you've declared them, I want you to once you've declared them, added values, I want you to then go adding new values to all of these variables. Now the thing to note here is you only need to declare a variable, var my weight, for example. You only need to do that once. So let's look here just as an example. It's okay to declare and initialize in 2 statements. So var x equals 5, document.write x. If we're in the same program though, and we want to give x a new value, remember you do not want to redeclare x because you've already done it once. So the declaration happens once, the assignment can happen as many times as you like. So for exercise 3b, I want you to make up some variable names that are valid, give them some values, and then replace those values with new values. Now, I'm not going to give you guys an answer key for 3b. I think you guys are able to do this on your own right now, but if you want, add some comments to the timecode, ask me some questions if you like, or email me about this if you have any questions about it. Right now, we're just scratching the surface of JavaScript's capabilities. We're really using it like a calculator for words and a calculator for arithmetic. There are tons of advanced operations that JavaScript can do. So here's a few examples. It can determine square roots, the tangents of a curve, return the positive value of a negative value, but we're not here to learn calculus, so I'm not going to make this very mathematics dependent. JavaScript can also do things to strings that are advanced, like removing all the characters E in a letter, removing all the letters in a word or a paragraph, finding and replacing words in a bunch of phrases, making a word go backwards or forwards, counting the amount of digits or characters in a string. But again, we're not in a writing class or a grammar class, so we're not going to push that to its limits. We're only going to be learning again today how to use JavaScript. That's the main point. We do need to learn one more operation that's advanced, and it's going to let us convert integers to numbers and integers and numbers to strings and vice versa. Now I'm going to talk about this and then we'll do a quick example before I assign the homework for today. So we're going to use the advanced operator called typeof. So kind of like document.write, it's just a word that's used by JavaScript. It's got brackets and we put a value within those brackets. So we'll write out this little piece of code here, test value 1, test value 2. We'll make test value 1 equal to the number 3, and we'll do test value 2 equal to the letter 3. I say letter 3 meaning the string 3. We'll write those to the screen, see that there's no difference, and then we're going to use typeof. So pause the video here for a moment. I'm going to open my file, and I want you just to copy this into a new file that you call advanced operators. Now that you've written the code down for test value 1 and test value 2, we can run it in the browser and see 3 and 3. They both look exactly the same. Let's try using typeof, all lowercase, to see what we're actually getting as values. So typeof test value 1, and then typeof test value 2. We'll send these to the screen, and you can see number and string. That's right, test value 1 was a number, test value 2 was a string. I'll copy and paste the break tags just to make sure that it looks orderly when I save this for you guys to read. There we go, number and string. And now let's see how we can convert between each string and number. And now with typeof, we can tell, did we convert from string to a number or vice versa. So here we have converting numbers to strings. This is called type conversion. If you look and we have the string of 2 multiplied by 8, it's actually going to give us a number. JavaScript says, if I see a string that has no letters in it, only digits, I'm going to assume that was a number. So JavaScript tries not to break. It tries to help you out by interpreting things. Sometimes this can help you. Sometimes it's a little wonky and it's going to throw you off. If we look here at typeof 2 plus 8, that's going to give us 28. We know that the number 2 plus 8 is 10, but JavaScript first thinks of this plus not as the addition symbol, but as the string joining, concatenating symbol. Remember that plus sign has double duty? So let's go back to our code and see how this kind of works and how it doesn't work. So if we do typeof, we'll make a new line, document.write, and we'll test this out. We'll put a break tag, document.write, type of, we'll say 2, the string 2 times 8. I'll copy these two lines just to make everything a little faster as you're watching. And then I'll say 2 plus 8. So we know that 2 times 8 is going to give us 16, but 2 plus 8 will give us 2, 8. It'll convert them to strings. It's quite odd how this behavior works, but that's a quirk of JavaScript. So first, 2 times 8, it's saying not a number, right? And then we're getting string. So 2 times 8, let me try that out. Again, oh, there we go, 16, even though it really isn't 16, and then 28. So when I'm trying to do typeof here, I should have put my brackets around 2 times 8. There we go. Just so it considers this whole thing a value. It'll do bedmass, order of operations. It'll get the value and then apply typeof to it. Same down here. I'll get the value and then apply typeof to it. So number and then string. So it's unpredictable in a predictable type of way. Now, as you can imagine, this isn't the best way to do things. There is an easier way to always convert a string to a number, and that's by using this function here. It's just capital N, number, and you put your string inside. That's always going to convert a string that's made out of digits to a number. Now know that JavaScript can interpret for you, so 711 written out with words 7 and 11 won't be 711, but number of 23 will. So let's go back to that same code we were just using. We'll add one more example with type of. I'll copy this one and try it out here. Type of, in this case we'll do number, leave those outer brackets, and we'll convert the string of 2. I know it's getting bracket heavy, let me add some spaces there for you guys. So number is one thing, then we've got brackets around number. Actually, I can drop the brackets. I'll save this, and we'll see what is the type of this, which that would be 2. We're getting number, perfect. Now if we didn't have the word number around it, we'd be getting a string. That's right, so I'll put number back. Now as a side note, you guys might have noticed at this point, if you hit a bracket, if you just click on one, it highlights the corresponding open bracket. Right? There we go, corresponding open one. So if you have an extra bracket and you click on the inside one and the outside one, you'll notice this one doesn't have a highlight. You know you accidentally had an extra bracket in there. So we're almost done with today's lecture. We just have to see the reverse, converting numbers to strings. And I'll go back to our slides for that. Oh, sorry, converting numbers to themselves. We've seen how to convert numbers to strings. We have parseInt and parseFloat. ParseInt is going to take a decimal point and convert it to a whole number. And parseFloat is going to take a string and convert it to a floating point number. So let's try this out with this code. You guys can pause it here, write these out, make sure your quotation marks are proper. You can tell on my PowerPoint slide, PowerPoint just wants to give me the curly quotation marks. Make sure you're using the right type of quotation marks. Try this out, pause the video, and I'm just going to go and paste it in and show you the code in a moment. So I've gone and written these few lines of codes into a notepad file, which I will show you right now. And here it is in Chrome. So as we load it up in Chrome, you'll see this converting values file. We had a value 4 and value 5. We said parseInt of 10.54. It gave us back just 10, right, as a number, because it dropped down, just dropped off the decimal, it didn't round. Value 5, it just took it as a full-on decimal point. So parseFloat, there you go. Again, both of these are number types. It's just how you want to handle numbers. Do you want them with decimals or without decimal points? I threw them to the screen by using document.write, and here you go with converting values. So that brings us to the end of today's lecture. It's almost 2 hours. We've been doing pretty good. I do want to hear from you guys to find out if it was too slow, too fast. You're learning a brand new language for the most part. This is a lot that you've taken in. Maybe you've taken a few breaks to get here today. I do want to hear how you're feeling though. Please leave a comment at any point in the video. What I'd like to do next is just show you the assignment I'm giving, which will be due next Monday's class. I'll say Monday at midnight. If you have any questions on it, you're taking more than 5-10 minutes and the same thing, something's not working, just send me a note, email your file in a zip file, or just copy and paste that code, like I said earlier, right into an email, and I'll be able to take a look and help you out. I really want to respond to you as fast as I can so you can move on. There is no point in sitting there for 15-20 minutes looking at the same thing and nothing's happening. You can always walk away, grab a glass of water, go for a walk, come back to it later. But trust me, as a developer, you will always be in this situation where you look at a piece of code, you don't see the typo, you see the typo about a day later, 30 minutes later. For you guys, you can send it to me and I'll be able to help you out and hopefully be a good second set of eyes. So here is the assignment. There are 4 questions, very much based on what the kind of stuff we talked about today. So I'll expect 4 different sets of files from you and different HTML files from you. The first question says the fortune cookie.
So why wait for your fortune when you can program your own fortune? Store the following into variables. So make up some variables that will hold number of children, partner's first name, city, job title. Output the fortune to the screen with a phrase like we did earlier, the way you will be an X in Y and married to Z with N kids. So number of children, partner's first name, city, job title, you'll put all of that in there. Then a few lines down, don't redeclare those variables. Give them new values, new strings, and do the same thing. So you will be an X and Y and married to Z with N kids. So in this file you're doing the same thing twice. You're just not redeclaring the variables. Okay, number 2, how old are you? So this year, I started the year at 31. I'm ending it at 32. Everyone has 2 ages every year, right? Your birthday isn't on, unless your birthday is January 1st or December 31st, you're going to be 2 different ages at different points in the year. So I'm asking you to make a new file, store the current year in a variable, store someone's birth year in a variable, and then calculate their possible ages. So you started this year at the young age of 31, you will end it at the ripe age of 32. Then just like in the question before, give a new variable, say your birth year, use some of the old variable values and write out the same thing again, just for a different person. So this year I will be both 27 and 28. Okay, again, if you have questions, write them in the comments section as I'm reading these, and I'll try to get to them. Number 3, lifetime pizza supply. So how much would a lifetime pizza supply cost? Assuming a few things. So let's assume that our lifetime is going to last until 2055. So I'd like you to store that value into a variable, store the value of a pizza at a cost of $9.99 into a variable, store the current year into a variable, and then assume that every day you're going to have 1 pizza for the next 40 years. So how many pizzas would you eat total? So multiply 365 times however many years between now, the current year, and 2055 in the future. How much money's worth of pizza will this cost? When you determine this, you might end up with a decimal point. Maybe it's 20,000.967332. Don't worry about losing the decimal points to make it look like a proper number with cents and so on. I'm okay if your decimal point lasts more than 2 places beyond the decimal. And then output to the screen, you will need blank dollars to buy blank pizzas if you plan to eat a lifetime supply of pizza over the next 40 or so years. Now you can change 40, 2055 if you want. If you want to get creative with it, go right ahead. And like I said there, don't worry about formatting your final value to 2 decimal places. Sometimes when you're rounding numbers or multiplying by a decimal point, you get some odd values. Don't worry too much about that. So now your 4th file is temperature conversion. I want you to convert the temperature. So store Celsius temperature in a variable. So give it maybe the value of 30. Then convert it with a mathematic operation to Fahrenheit. And you'll see I've given you the way to do it. If you're going Celsius to Fahrenheit, multiply your variable number by 9, divide it by 5, then add 32. Then do the exact opposite. Right, convert a Fahrenheit temperature into a Celsius temperature. Put that to the screen. Now, if you've been paying attention, I've talked about putting HTML to the screen. See this degree symbol? That's a little bonus mark. If you get the degree symbol printed on the screen, you'll get a bonus mark. That's it. So you have 4 questions for next week. There's a lot to take in. These questions are really meant to make you save files, use basic arithmetic, declare variables, output them to the screen. Like I said earlier, if you're having trouble with getting these files to work, don't worry too much about it. I'm happy if you submit something that doesn't work. You might still get 90%. I just want to see all the places, all the things you've written down, your variable names, the way you're thinking about things, add some comments into it. If there's 1 semicolon missing on each of these files, which breaks everything, you're going to get probably 95%, if that's the only thing that's wrong with it. So just having a typo that you're not able to see doesn't mean I don't want you to get worried, don't want you to think I'm not going to submit this in time. Just submit it. I'm going to evaluate your work, not the fact that it is working or not. So I hope you're having fun with JavaScript. It's going to pick up from here. You've just learned all the basics of a new language, which is pretty exciting. These are things you do in your everyday. Very basically, like rock, paper, scissors, building a peanut butter or jelly sandwich. These things take you no time to comprehend. But for a computer, you really, really have to spell out all of the rules. So hope you're proud of yourself. You've come this far. Let me know how you're doing with the comments on the video, or send me an email. Can't wait to hear from you guys, and I'll be checking up on you throughout the week, hopefully. Thanks for listening to Lecture 1, and I'll talk to you next week. Bye.